So welcome back everyone. Now we're going to learn about the addressing modes and their types. So we already gone through the addressing modes. So now we are going to learn about the addressing modes and its types. So first one first, which is immediate addressing mode. So we need to write immediate addressing mode. So what does it mean? Actually, let's write it in short way because we are learning engineering. So I'm not teaching you English. Immediate addressing mode. That's it. That's how we learn. Okay, my dear friend. So let's begin. So this is immediate addressing mode. What do you think it is? Um, let's write the definition. Then we will learn this. This addressing mode includes the the instructions in in which data is directly LY directly given in instruction. That's it. That's all it means. And you remember that we have done something like this 8105. Now, this is the example I would like to present you. And what it means? It means add, AD means add immediate data 05 to accumulator. Remember that A, that was our accumulator that was collecting data. We will discuss accumulator itself in detail. But for now, this is what immediate addressing mode means. So what immediate addressing mode actually do? You might be pondering that then what it actually do. Well, it do a very simple task. It includes the instruction of the data and direct the instruction. That's it. So it adds the data to the accumulator. Or you can say it loads the data, but the loads is actually not technically the correct word, so I have not written it. Okay, now let's learn about the second addressing mode, which is our register. So now we have register addressing mode. So in register addressing mode, what we actually study? Well, you learn about the register. In this type, let's write it also. In this type of addressing mode, data is stored data is stored in same register in same register. So that's it. Let's take an example also about this. Well, example here that we have is add b. Well, you remember this one, right? Here the data or the data, whichever way you like to call it, is stored in register B. So this is the simple task of this. It just stores data, nothing else. See how simple the things are? Still we have new things coming up again and again. Now we have direct addressing mode. We completed the register. So it's time for the direct addressing mode. Direct addressing mode. So what in the direct addressing mode it actually means? In this addressing mode, let's write it. In this addressing mode, data is stored in same memory, in same memory memory location, in same memory location, and the address of that memory location is given directly in the instruction, in the instruction. Now let's take the example, then I will explain it. I can read that LDA 2050. Let's take it like this. You can take LDA 2972, whichever way you like to call it. This is just the part that a number, that's it, nothing else. Okay, I'm just taking LDA 2050. So what it means? It means load. So this is the load. LD means load. Load the content. Load the content of memory location of memory location 2050, which is here, which is here 2050, to register to register A. A is our accumulator, right? So that's what it means. So here the the address is given directly in the instruction, in the instruction that is 2050. 2050. So that's what it means. It seems a little bit lengthy, but it's not actually. Okay, let me take back the page. That we are here. We are. Okay, the page slipped by a little bit. Don't mind. Okay, in this addressing mode, the data is stored in same memory location, and the address of that memory location is given directly to the instruction. So it will not going to tell me that what is the data. Instead, it will going to tell me what is the address itself. So processor knows that what's the address is, and once you reach the address, you can surely have the data. So this is loading. So the loading thing don't actually tells you the data, it tells you the address. That's it. That's all it. Now we studied the direct addressing mode. So something is called as indirect addressing mode. So let's study that. Indirect addressing mode. So what it actually means. So in the indirect addressing mode, let's start it like this. The data is is stored in memory location actually. Memory, let me write it in a good way. Memory location. Now it seems a pretty clear writing, right? At least to me it is. And the memory location. Memory location. So indirect addressing mode is telling us this thing, that the data stored in memory location and the memory location in another in another register which is given which is given in the instruction in the instruction. Now let's take the example, then I will explain both of them in just a while, so don't get worried about anything. Okay, so here we have ADD, well I'm sure you remember this, and M, the memory one, right, you are intelligent my dear buddy. So here ADD, data, whose address whose address is stored in register AR. Let's say AR is our register in this case. This is called, or you can say this is also called register. Indirect addressing mode. Now, don't mind my writing because I'm writing a little bit quick. So I hope still you can figure it out. I'm just saying that all the things again. Add data whose address is stored in register AR. This is also called register indirect addressing mode. Here the address of data is stored in register AR. Now let me explain the thing. What is the direct and indirect? Imagine, well, now we have to imagine. So let's imagine. So this is our imaginary world. I want to reach to the home because I want to find my instructor. So how I can do so? Well, the first way is just ask home. Well, ask me and I am going to tell you. This is direct way. And what is the indirect way? You will search a contact of mine, search a contact that can bring you to another contact, and that contact might bring you to me. Now, in our case, this is email or Udemy feedback that you can give me. Udemy feedback, and maybe your precious comment, appreciation. I also love critiques, but make sure you do it in a good way. Okay, so with all these things, you can approach me. Hmm, that's the way. So this is the direct way, and this is not the direct way. So this is indirect way. That's how it's working. Now let's connect it from here. Indirect addressing mode. What we said 2050. Load address 2050, and that 2050 to the processor give us the data. That's the thing. But in indirect addressing mode, what we are having is we don't have the memory location exactly. So we are having an address that will tell us another address which carry the data. Well, if you studied the programming language, you know surely about something marvelous called as pointers. So pointers store the data. No, pointer stores the address of the data. Address of the data. So this is known as pointer, and this is what the indirect addressing mode is actually pointing out to you. So I hope you have understood this one. So with this we have completed our indirect addressing mode 2. Now it's time to learn about implicit addressing mode. So it's the time to learn about implicit addressing mode. So let's do it. Well, to learn the implicit addressing mode, in this addressing mode, in this addressing mode of instruction, well, we are giving the instruction address of data, address of data is not defined, not defined. You are lost, you have to search me. In the instructions, well, if you are trying to search me, you just have to mail me because I am not available on Instagram, I'm not available on Facebook, I'm not available on Twitter. I was available on all these places, then I thought it's better to learn because it was wasting my time. I was not very much conscious that how much time I was wasting in there. Well, if you use it consciously, that's a great place to be because I made so many of my friends, teachers, and so many people. It was a wonderful experience. But you can call it that I am on a big break, that I'm not using it since some time, like a few years. Okay, so this is the thing. I am implicit addressing mode, but the instruction is known. But the instruction is known on what data is has actually it has to perform execution. So let's learn this first. In this addressing mode, instruction addressing data is not defined. So you do not know about the address. So instruction do not know about the address. But the instruction is known that on what data it has to perform execution. It knows what to execute, it knows on which data it has to execute, but it do not know where it has to be executed. Now, that's a very weird thing. Like it's something like we were looking a Earth-like place. We don't know its address. We don't know its exact address, but we surely know that what are the things we are going to instruct. Like what are the resources we want it from there, and what are the executions we are going to perform. Hopefully, we will not produce the carbon emission and pollution all that such place, and that's all. But the main thing is we don't know where to perform all that because we don't have that second earth address. That's not so much cool, right? So the example that I would like to present here is CMA. Well, as you remember, this is complement of A. So this is complement of A, complement of A. Well, what it is doing here? Let me explain. Here the address data is not given in the instruction. Address data is not given, right? So what is our option that we can have? When address data is not given, but the instruction is known, it has to be complement. But instruction is known, right? So we know that what we are going to give the instruction. Instruction is known. Like we will land few soldiers, we will land few agriculture land, we will have the water resources, we will have the things and stuff so that we can start our day-to-day life. We know all that thing, but where is the second earth? I don't know. Okay, you might argue that you know about that because it comes in the news. I don't know means I really don't know. Because we cannot reach it, it's useless. So, this is all about it. Um, so that's why we use the implicit addressing mode. Now, why and how it is working? Well, I will tell you something about this. Imagine you have to hide something. Which addressing mode you are going to look at? Implicit addressing mode. That's it. That's the way. Well, it is used in so many variety of the ways, but I don't use something that seems quite simpler so that we can understand the things. Okay, now let's see. We have done with our implicit addressing mode. Now it's time for the increment and decrement that I can explain right here. So we do not require something new. Increment means incrementing the value. Like if I write plus plus on something like x plus plus, it means if x is initially 1, now it will going to be 1 plus 1. Actually, this means add 1. That's it. That's the meaning of the increment. So now it's 2. After the whole execution is performed, now it will going to be 3. Now it will going to be 4 and so on till the command is given to whichever number. Like if I produce it to the x to the 1 to 5, so it will run till the 5 and then it will terminate. Same way, if you reverse it, that means x minus minus. Like if I initialize x equal to 5, then it will be x equal to 4, then it will get x equal to 3, then x equal to 2, and then x equal to 1. So this is the way it actually happens. I hope you have got this, and this is quite simple. If you learn the programming, this is very basic thing. And now it's time to learn about the relational addressing mode. So let's learn it. What's there in the relation? Well, that is one of the most important things in the human life. Relation addressing mode. So we are building the relation, the student and teacher relation. I love you, my dear friend. I love your dedication, your working, and my working too because I am also working hard. Okay, so in this addressing mode, in this mode of the content of program, I would say counter is added. Remember the counter thing? So counter is added. Now something is going to count on us to the address part of the instruction to obtain the effective address, to obtain effective address, effective address. Like one of the way is you find me directly, like here is home, or the other way is look everywhere and then come to home. Well, which way is good? Well, surely anyone can say that the path 1 is better because part 2 will take going to take lot of the time. Third counter is going to see, it will going to see that which path you are choosing. Like you choose the digital electronics to study everything, and this the 4 year of the crux that we have learned in our engineering. This is my favorite subjects. This is not the subject, these are the subjects that I am telling you and I am teaching you. So this is the way it actually happens. And the address part of the instruction is signed number. That could be positive or negative. This addressing mode can also be branch type instruction. So let me also write few of the points so that you can also see that what I am saying. So it's a signed number. It can be positive and negative. Well, what are the signed number? Let me give you a brief glimpse if you have not familiar with the programming languages yet. Signed numbers are the defined limits. These are the defined limits. The lowest limit is defined, the highest limit is defined depending upon which programming language you are using. It is already defined. Like if I define minus 251 to plus 251, so this is the limit, and between everything is there. There is no unsigned number. It is known already. Okay, this is about the signing thing. And we can have the branch type instruction too. So what is the meaning of the branch type instruction? Well, there can be linear instruction and there can be branch type instruction. Like imagine if in our spreadsheet I have to change so many columns. What I do, I just select them all and maybe plus one or increment. Let's say I incremented. So every of the value, like say 5, 4, 3, 2, 8 are the values in our spreadsheet in our definite columns. So if I select them all at once and increment it, so what is going to happen? Everything will going to add up with 1, and here I mean addition with the increment, so don't get confused. 6, 5, 4, 3, 9. Now these are the new values on these places. So that's what I meant with the branching of instruction. Well, this can be called as a linear one, and we can also branch it like this one. Like one instruction is affecting so many things. Like I say 2x by 5 and 3x minus 8, 4x plus 5, and the previously the value of x is 1. But now if in some case I change from 1 to 2, now it gets branched. Every of the branch has to change. That's what happened. And this is called branch type instruction. I'm giving the branch type instruction. I gave you the simplest way possible, simplest version possible. Not necessarily this is happening, but who cares until the logic satisfies, because ultimately we are studying the logic, we are studying the fact. But anyway, it is the fact. So I told you this one. Now one more line I would like to add in relational addressing mode, that I would like to write it here, which is effective address effective address is equals to program counter plus address part of instruction. So this is all about it. Effective address is program counter plus address part of the instruction. Well, you can treat it as a formula, relation, or whichever way you like to call it. This is all about the relational addressing mode. Okay, I hope you have got it. Now let's proceed to the next level. Well, now we have the second last, indexed addressing mode. So let's learn indexed addressing mode. So what is indexed addressing mode? In this mode, counter of an index address is added to the address part of the instruction to obtain effective address. Well, what I actually said? Well, I just said that it's a mode. Like, what is the index? In your notebook you make index. This is the first page. Generally in the lab notebook we have like experiment number 1, we write it here, experiment number 2, we write it here, experiment number 3, we write it here, experiment number 4, we write it here. We write the names of these experiments, and we also mention the page numbers, from which page number to which page number it is there. So this is called as indexing. So this index is going to help us to figure out, like if I have to check the third experiment, I know which page number I have to go. I can directly open that pages. This is the meaning of indexed addressing mode. I hope you have got this. No need of any kind of the definition in this. Well, why I have written so many of the definitions? Can you tell me, my dear friend, why I mentioned these many definitions? Well, this is to present two things. First, the instructions, like here, how we are actually and practically using the assembly language. And second, these English lines that I have written is just for the practice purpose. You can read it again and again. If I say it once, maybe it can skip, but if you're watching, seeing, and working mind, it will surely fit into us and we will keep this for our lifetimes. So, this is the only purpose, the intentional purpose of writing it. But I don't think it is unnecessarily required here, so I just gave you the best example, like an increment and decrement I did. Okay, like right here. So we have covered the indexed addressing mode, and now we can proceed to the next thing, which is our base addressing mode. Base addressing mode. So what is the base addressing mode? In this mode, the content of base address, the content of base address the content of the base address, let's say I'm removing the address word here, base register. The content of the base register is added, is added, is added. Okay. To address part, to address part of instruction of instruction to obtain effective address. Well, I would also like to mention one more line, then we will come to what it actually means. You can just note down along with me, as I recommended. This addressing mode is is used for relocation of program in memory. So that's all it I want you to learn. In the base addressing mode, well, name itself seems like there is an army camp, right? So there is an army camp or our base camp that we have to return all the time. So the content of base register is added to add part of the instruction to obtain effective address. So to get the effective address, we need to add it up. Like there is a list of all the officers or all the students in your class, and then teacher ticks or mark the present and absent kind of thing in front of the name of the students, and that is going to tell us that who is absent as our base camp. Well, generally in the classroom. So this is the classroom thing that we are having. So classroom is the base camp in this case. So that's all it. This addressing mode is used for the relocation of program in memory. We can also relocate it in the memory. Like when in the practical life, when in our class you pass some class, you reach to the next level. Like you are on this section, it means you have gone through all the previous sections and then only you reached to this one. So with all that said, this is it for the section. Well, not the section technically, addressing modes. We are finished with all the addressing mode and we have covered all the things that we require to learn and we learned it successfully about I R D I square A R I B. Well, you can sing the song just like me to learn the more things. So these are the things that you just learned, and it brought you so much kind of the information and excitement, right? So yes, we have also discussed this thing. I cannot forget this. Okay, so here the next one where we are going to study and understand what is instruction cycle. Well, this is the most exciting concept. Why the instruction cycle is important. This will going to be the basis for our integrated circuit or microprocessors. Whenever you learn the microprocessor, you are going to learn about the instruction cycle. That's the whole game of the microprocessors. So stick with me to learn more, and we will learn the instruction cycle in the next one. Till that time, take care, see ya, and have a nice time.